Okay, welcome everyone. Tonight we're very fortunate to have two of the core contributors to Pandas, Andy Hayden and Chong Shah. Chong is also the CTO and co-founder of a really cool analytics company, DataPad. And so please join me in welcoming them.
Andy, why don't you come on? Hi everyone. Thank you for the introduction. So I'm CTO co-founder of DataPad. My co-founder is Wes McKinney, who created the Pandas library. Wes and I moved from New York about roughly 18 months ago. We're both recovering financial quants. I say that like I'm a recovering alcoholic. I'll let Andy introduce himself.
I'm Andy Hayden from the UK as an analyst and software engineer over there. So data scientist here, I guess.
So before we get started, can I get a show of hands? How many people are Python programmers here? So everybody. How many people have used the scientific Python stack? So Numpy, Pandas. It's like, okay, great, awesome. How many people are here just for the free food? No, I'm just kidding. Okay, so what are we talking about today? So first, high level, why Pandas, right? Pandas came a lot later than NumPy. So if we had NumPy, why do we need Pandas? Why Pandas was coded in Python? Why not R? And sort of high level, what are the main ideas in Pandas that didn't exist before, and what are those things, or why do those things make Pandas very popular? And then we'll talk a little bit about performance in Pandas and the process of how we improve performance and track performance. And in fact, we'll do a little case study of how to use Pandas to analyze Pandas performance over time. And in there, we'll throw in just a few brief notes about the sort of core data structures and algorithms in Pandas. They're actually surprisingly simple, and we'll talk about how the API design and the course of open source development drove the design for those data structures. And then, so Andy has the dubious honor of the most frequent answerer, I don't know if that's a word, on Stack Overflow for Pandas questions. So he's also got a collection of sort of bad idioms and pitfalls that we've seen over the years on Stack Overflow, and we'll talk about what are the best solutions.
And if you have any questions throughout, just shout.
Yeah, absolutely. Feel free to interrupt us at any time with questions. All right, so what is Pandas? It's really a Python library for analyzing real-world data. And I say real-world meaning it has NAs, data might be dirty. You might have to put together different data sets, and then you have to do data alignment and things like that. It's often an iterative process. The library was, of course, created by Wes. It was born out of his pains working in finance, which I was also a part of. And I think after he left AQR Capital, which was where the library got started, he worked on it as an open source project. In 2012, I joined him as sort of another contributor to Pandas, and together we built up the community. It's now, since we started DataPad, the project has been taken over by Jeff Freeback in New York, and a lot of other open source contributors that I don't have enough slides to name. Just very briefly about Pandas, it's supported on all the platforms. Everything's tested. Every new pull request, every commit is tested on Travis CI, and it's also tested on Windows. And occasionally, I get angry emails from Yaroslav, who's the Debian maintainer, saying that it doesn't work on little Indian machines. And as of the latest version, it supports Python up to Python 3.4 now. And then, oh yeah, so I forgot if I mentioned Windows already. We do have a separate Windows Jenkins instance that compiles all the Windows binaries and make sure that they're all tested, right? And whether you go on GitHub or you go on Stack Overflow or the PyData mailing list, you'll see that there's a really big and active community for support. If you have questions, if you have new ideas, if you have pull requests, there's a lot of places for you to go. Right? Oh. Oh, there we go. the hide link doesn't seem to work. All right, so sort of highlights of big ideas in Pandas, right? So the first thing is label data and automatic alignment. So I think there was a recent blog post, I think by John Miles White, that talked about how you should never try to add two matrices together in a lot of different tools, and it's because if they have different sizes or if the alignment is off, it's often the alignment of the data is often implicit to the data structure, and so when you try to operate them together, you often get nonsensical results, but you still get results, so you don't get any warnings. Instead, in Pandas, everything's labeled, so data alignment's automatic and everything's explicit. And so that's sort of that's actually the original impetus for Pandas. Or it started out as very thin wrapper around Numpy arrays, both one-dimensional and two-dimensional, and the labeling and automatic alignment was the first big feature in Pandas. Secondly, Pandas makes it easier for users by having a lot of different data integrations. So in a lot of real-world workflows, whether you're a data scientist or a data engineer, you have to work with a lot of different data. And if you're in a lot of companies, you have your in-house enterprise data warehouse. You might have Google Analytics. You might have you might have big data infrastructure, like you might have Bigtable. A lot of different ways that you would need to pull data together and then interact with it. Right? And then with Pandas, you have a single interface that can pull data from various different sources and then normalize them all into one data structure, so that once you've ingested the data into Pandas, then you no longer have to think about where did this data come from and have that impact how you work with the data. And very quickly, since a lot of you guys have already used Pandas, you've seen flexible slicing and dicing of the data, and Pandas is about analytics made to fit your brain, not vice versa. Right? And so the alternative, a lot of it is do it in SQL. So when I was working at AQR Capital, a lot of the analysis that we did ended up being encapsulated in about a 3-page SQL stored procedure. Right? And this was terrible because it was impossible to debug. It was impossible to iterate on, and it was impossible to version. And moreover, and also the analysis, once you get the data out from SQL, is often had to be done in, let's say, Excel, right? So you get a result, and you have to email around the Excel worksheet, and then somebody says, well, how did you get this parameter? Let me play around with it. So little do you know, 10 minutes later, that network drive has like 10 different versions of your Excel workbook already. So, but by encapsulating it all in code in Python, everything's versioned. You're versioning the code. You don't have to version SQL procedures. And the difference between a Python script to do analysis on data versus SQL is it's sort of the breakdown between relational algebra versus relational calculus. And with relational algebra, the way that you do it in Pandas, it's procedural. It's much simpler, and things like Pandas group by provides context, and then subsequent operations, you can sort of discard this context in your mind, and you don't have to run into buffer overflow problems in your own mind, right? So
if you really like SQL, then there is like an interface for pandas.
Right, right. You can write to SQL and you can read from SQL.
Well, I mean, you can actually query your pandas data frames.
Oh, right.
If you really want to.
So you can, yeah. So if you're really a glutton for punishment, you can write a SQL query to get data into a pandas data frame, and then write SQL against that data frame. All right. So all of those sort of combine into one overarching goal, and that's user productivity, right? So all of the APIs, data integrations, and performance optimizations have the final goal of making the user more productive in mind. Right. So how do we do that, or how is Pandas able to achieve that? So first of all, I mentioned a lot of different data integrations. It's a single tool that allows you to interact with very disparate data sources, and what that does is it minimizes the cognitive dissonance that you go through as you go through your analytics workflow. It prevents context switching in that case, and it minimizes context switching in other parts of the workflow as well. So if you break down the analytics workflow, you have ingestion, sort of data discovery and exploration, and then you have a sort of a publishing or collaboration step, right? But except it's never a single linear phase. You ingest your data, then you have to sort of look at it and figure out summary statistics, maybe look at it in a chart or something, and then either you publish or you figure out, okay, crap, I forgot to treat NAs in my data source, then you have to go back, or I have some bad data here. With a lot of traditional workflows, you have to use a different tool to get to the data, or you have to use a different library. Whereas with Pandas, you can bring the data in, and then you can keep working on it as a data frame, and iterate on it, and look at it and analyze it in a cycle, right? And moreover, Pandas is pretty fast. It's not as fast as Fortran or AllC, but it is performant enough for iterative work, right? You can make Pandas function calls on decent-sized data, and I think Wes has been dubbed the king of medium data at this point. And what we mean by medium data is data that's too big for Excel, but data that's too small for Hadoop, but too big to be stupid about. So we have to make Pandas fast enough for interactive work. If the user runs a function call and has to wait 30 seconds, a minute, that's a disruption to the workflow. But if we can speed that up to, say, 5 seconds, maybe 10 seconds, maybe acceptable, right? Okay, so let me jump into a notebook very quickly on Pandas Basics. Apologize while I do some context switching here. Okay.
I have to give it to you somehow. Log in again.
Okay. Okay, so did everyone actually read the text? No? Okay. So. Is that better? Larger or larger?
Yeah.
Okay. Is that okay? All right. Okay. All right. So I've prepared a small notebook to illustrate some basics for Pandas, and we'll sort of break it down into roughly some of the categories that I've talked about. The first thing is data ingestion. So I'll use ingesting data, reading data from SQL and writing it back to SQL as an example. So, I'm sorry? Even bigger? Okay.
One more.
Yeah? All right. Everybody in the back can see it? Excellent. Okay. So, I think it was a fairly recent refactor that made Pandas now depend on SQL Alchemy for its SQL interactions. So I created a fake SQLite database that's in memory, and as you can see, I'm using the latest stable version of Pandas. So what I'm going to do is, I'm going to load a CSV file of everybody's favorite data set for data visualization, which is the diamonds data set. And so first of all, you can see that in Pandas we've got the read CSV function, and what that gives you is it turns a CSV file into a data frame, and you can see that we can describe this data frame based on the number of the columns and some stats about the columns. And in fact, it describes the numeric it describes the numeric columns here, but we can also look at the head. We can look at the tail of the data frame, and you can see that the describe function omitted the non-numeric data, but we actually have more columns. And you can pass in an optional parameter here to show a custom number of rows. And now that we've read the data frame from CSV, we can write it to SQL and just call to SQL from the data frame, and you can give it a table name and then the database. And index false means that we are not going to write the index here into that SQL table, right? And since this is just an illustration, we're going to read it right back out. And we'll see that we get the same data back. And of course, instead of reading the entire table, you can use read SQL query to actually pass in a custom query. Here I'm saying select everything from diamonds where color doesn't equal E. And as you can see by comparing the head, indeed that all the rows with color E up here is now gone. Right? So we saw read CSV here, and writing to SQL and reading from SQL. And there's a lot of different data integrations in Pandas right now. There's Google Analytics, BigQuery, PyTables, Excel, Stata for if anybody's a statistician or political scientist. You can have HTML tables, and there's a beautiful soup integration there to extract data from HTML tables, JSON formats, to and from clipboard, and some message pack and pickle integration. And then there's also other sort of data source reading integrations like Yahoo Finance, for example, and for the financially savvy. And for the read CSV functions, it's not just comma separated. You can choose any sort of delimiter, any sort of file format. You can have instead of delimited formats, you can have fixed width files as well. And so oftentimes the data integrations are some of the most high leverage pull requests that new contributors can make, which is a new data format. There's a lot of commonalities in the APIs and the underlying implementation structure. So you can take a look at how one is implemented, and that will help you tremendously to implement another one that is specific to you. Question. Yeah, so the PyTables integration is for that. Yeah. Any other questions about the data integrations?
the HTML is really easy for scraping. It just, if it's like paginated like tables or something, it's ridiculous. It's really
Okay. And of course, once we get the data frame, now we can use Pandas to slice and dice the data to actually look at it. So we've seen the describe function before, and the data frame has a bunch of different parts. So we talked about label data. So we have column labels as df.columns, and row labels as the dot index property. We have selection. You can put in any expression, Python expression here that produces a Boolean array, and we can look at the results. Right, anything with price over 10,000. And so there's multiple ways that you can get data out of a data frame, and they're a little bit different. So the IX property is the most flexible. You can pass in a mix of label-based and index-based, but oftentimes, because that was the original rich indexing feature, but what users saw was that when your labels, either column labels or row labels, were also integers, it can lead to some confusing or at least unexpected behavior. Right? So then we made the loc and iloc properties here, and basically loc is purely label-based, so everything is treated as a label, and the iloc is purely number-based or purely index-based. Everything is treated as the positional index. So I'm getting the cut and color columns here. I'm retrieving the first five rows, and as you can see here, I'm calling .loc with 0 to 5 here, and because loc is purely label-based, I actually get a key error. And with IX, it's a mix of the label-based and positional. And so I'm just going to omit the last column here for the next example. Any questions at this point? How many of you have not seen anything that has been presented so far? Okay, all right, cool. It's not been a complete mistake. Okay, so I think the third major area I want to hit on as Pandas Basics is the split apply combine approach to data aggregation. Right? And so one of the most powerful things in Pandas is grouping a data frame. So I could call data frame.group by a field and then a function, and it could give me the sum by cut of each numeric column. I could, of course, group by multiple columns here, and when I just call group by, it's a data frame group by object that's given to me, and that's essentially a staging area. And what that gives you is it maintains in memory the grouping indexers, and it helps you then to compute group aggregates and contains all the metadata necessary for that. So I can have custom aggregation functions other than the defaults like sum and mean and things like that. For example, here I can compute the mean divided by the standard deviation. And I could do something like using apply. Oh, this is let me see if I can read live coding. It's going to go really great. So now that I've enlarged the font, allow me to make this a little bit easier to read. It's not an aggregation here. Okay. So in addition to aggregations, I can also perform transformations on the data. So let's go back just one second here. So when I give it an aggregation function, the function will return a single number, and that number is computed per group in the group by. Instead, if you use apply, what you can do is give it a function that instead returns a data frame with the same dimensions, but with the data transform. Right. So here, as you can see, I got the same columns back, and actually it's going to be the same number of rows. So what I've done here is I've selected the numeric columns out, and for each numeric column, I've subtracted the mean. Now, when you apply it to a group by, this mean here is not the overall mean of the data frame. Instead, it's the mean per group. So here, what I've done essentially is, make sure that the in-group means are all 0. So here, what I'm going to do is verify that the results are what I expect. So I'm going to group the results by cut and color again, and then I'm going to compute the aggregate mean per group, and I'm going to round it to 6 digits. Right? And so as we can see, we can verify that all the group means are now 0. Right? So any questions on this part before I'm going to switch over back to Andy's laptop? Okay, question over there. This is just on a data frame. Yeah. Panel group I should work, yeah. Yeah. Panels have not seen nearly as much love as data frame. Although I will say that for most use cases for panel, you could do the same thing using multi-indexing. So and that's actually oftentimes easier to reason about.
And to visualize, I guess.
And to visualize than using a panel data structure.
But if you're having problems, file a bug on GitHub.
Yeah.
So we know about them and can fix
Jeff Reback is the current lead. I'm not sure if that guy ever sleeps. So usually you should get a very quick response if you post a bug report on GitHub. Yeah, there's another question back there. Yeah. Sure. Oh, because these are the row labels. So so what I did was, okay, let's go back to the original data. So I've been using this foo data frame, and I generated foo by filtering the original data frame. So it's whatever the filtered row labels were. Other questions? Oh, if you just want to do like reading data in and writing data out?
Depends what you're doing.
It's a minimal process. It's sorting. No heavyweight analysis.
Right. Yeah, you want an answer for that already?
I guess the data frame or like isn't always the right data structure for it depends what you're doing really. But if you're talking medium-sized data or large data, then it is a good choice. And also for rapid prototyping, definitely. But if you're coming into like performance issues on specific parts, yeah, it could be worth using some different data structure. It's not.
I mean, if you. Sure, yeah. Well, I think there's a couple of ways to look at it. You know, how in your program, when you're talking about lightweight versus heavyweight, how much weight actually matters, and what does the weight mean? So if you know if a few kilobytes of memory actually makes a difference for your application, then you probably want to consider something that's more lightweight. You probably wouldn't even want to use NumPy for that. But you know, if it's just number of features that you're worried about, I would say you don't have to. Yeah, well, I think installation for Pandas is not so bad, especially like if you're on any Windows platform with binaries. If you're on Linux, it's easy. If you're already using NumPy, then most of the headaches for installation comes from either having to install NumPy or sort of build NumPy if you don't already have it. So I don't think, at least in general, I haven't heard that as like a thing for users to be really concerned about. I think there was a question over here too.
Do you depend on NumPy?
Yes.
So we have to install the right version of NumPy in order to use
We support multiple versions of NumPy. I think generally like 1.7 or above should be fine.
1.6 works, but there's some datetime
so if
issues. It's a bit hairier.
Yeah, it'll work with 1.6, but there's NumPy bugs working with the datetime 64 D type. So really, the best choice is NumPy 1.7, 1.8.
Resolve all the dependencies.
Yep. Yeah. So if you have Anaconda, everything should work perfectly fine. All right. Switch over. Oh, okay.
Okay. So Chang was saying before about performance and it kind of looking quick when you're at the terminal. Oh dear.
All right, there we go.
Okay.
I think. Okay.
So this is we're just going through what you were going through. Okay. So because what you want is when you're doing your like exploratory data analysis. Oh.
Yeah, you got to do this.
I see. Sorry. This one here. Entire screen. Where was I? Maybe I was here? No. No, I think this was just full screen.
Perfect.
Yeah. So when you're exploring your data and you want to see what see what's going on, you want it to be snappy, really. So you want to be typing in your apply, your summing, your describe, and you want it to be in front of you. You don't want to be waiting multiple minutes. And the way that we track it in Pandas is use this tool called vbench, which again Wes created. They use pretty heavily in Pandas. So if anyone is writing anything that looks like it's touching stuff which is performant important, then we make sure we run to check that it's not. Okay. So the question is, what do you track? I mean, we could just track everything, all of our tests, but we don't really do that. We get the tests which have like 10,000 items, different or group bys which have either few groups or lots of groups, because that changes the time of how those algorithms work. Other people who are using vbench so there's a NumPy unofficial. So here's a NumPy. Again, it's this Yarek, who is a Debian maintainer, and so you have this list of Python scripts that you run, and it basically checks when you do your git commit, it looks at a previous git commit and compares time of each of these. So if we look at an example, so here we're looking at some join merge. Can you see this? It's a bit small. I'm not going to be able to see it on this. So it's a lot of evaling, basically. So you have your script. You have to import a load of stuff. So it's pandas VB import, which is everything from pandas, everything from Numpy. And each bit you want to benchmark, you put this string of your script and basically run this whole thing in this benchmark class. So that's all the setup was that string before. We were like preparing the data frame, and then what we want to time here is the join between the df data frame and df underscore key one. So the setup is a string above, and then we name this test basically. And so Pandas has 500 of these benchmarks, and each commit you can test. But what we really end up doing is checking if like I say, if we're touching something that's in the CFON, we want to see if the difference between that and between master. So yeah, and scikit-learn are also using this too. So there's some scikit-learn speed branch. Okay. And why do we do it? Well, so like I was saying, if you're a user and you're typing in your data frame, doing your reply, and it's snappy, and then you update your pandas, it goes to a stop, you're going to be upset. And people are often upset, and we'll get their grievance. But because it's so easy to time stuff in pandas, if you do think it's slower, use your time it, and then complain. And we'll add it onto vbench.
I'll just add to, like, one of the other main impetus for vbench is motivated in the early days of pandas, when there was a shooting match between pandas and R. We'd often have to track performance and make sure that pandas performance was faster or as good as the R libraries.
And there's some really interesting blogs, mostly by Wes, about algorithms and stuff you use, but maybe we'll talk about that in a second. But yeah, so the part of the reason, like Chan was saying, but also to stop these legitimate grievances before they're anyone's grievance. Okay. So let's look. So I run this. So most of the time, can people see? No. I can only see one line on my laptop.
You can do hide the header, toggle the header in the toolbar. Go to view.
What's that?
Go to view.
Oh yeah. Oh yeah.
And then just toggle the header and toggle the toolbar.
I'll never be able to get them again. Okay. So like I said, most of the time you actually just test it from the tip to the master branch. So this is the oft-used test performance script in Pandas. And it runs all of these Python scripts that we were just showing. And there's some description of that on the wiki. But what you can also do is you can test every day, at the end of the day, or every commit, and run all these scripts, and wait a long, long time, and it fills up SQLite database, and we can have a look at that now. I ran it this morning. So here I have my benchmarks database, which is filled up, and this comes with a few tables, and I just read them in. I'm not sure why I had that there. So the benchmarks table is just this list of all of the Pandas scripts that are being run, and that's what we're timing. And that's on the master which you're timing, and you're timing against previous commits on that same script. So the script isn't changing. Because obviously if you added a load of, or were timing something different 5 versions ago, you don't want to be testing that, because it will make it look like you were much faster before when you're not. Okay. So this has a load of checksum information as well to make sure, and the results are the timings. So if we have a look at this, you have to merge these two together to see. I can't see it. Okay. So there's a lot of nonsense stuff here where there's the checksum of files, revision, but you can see these. This is the timing information, and this is the name of the test, which we just saw before somewhere. This is the name. Okay. But really, the only interesting ones are the name and timestamp and the timing. So if I plot these, you can see overall, this is just a week, a month, and so there's not much interesting stuff going. This is just everything, or this is like 40 tests. But actually, when I left it in my bag when it was running a test. And so I think my CPU is heating up and stuff is so I think that's really the reason for that increase, rather than some terrible commit on, because just before the release. So this was July 10th was a release.
It would have to be a pretty bad to have big of an impact overall.
So sorry about that. I meant to do it last night, but I made a mistake. So I had to rerun it on a smaller subset. But then you can look at individual test cases and see, again, that's from in my bag, but this probably down there is a legitimate test. I think like it's slowed down, so it's probably worth checking back. What's the word?
Bisect?
Bisect, yeah, bisecting to find out what has caused that, and fixing it, or seeing if it's worth fixing it. Often it's just a new feature has been added there, so you're doing something slightly different from before, so maybe your function has some new arguments, or so. Okay, so what was I doing here? So yeah, that was, so it's really interesting to look back from revision to release to release to see that all of the things that you care about aren't getting much slower. Or if they are, why are they, and can we correct that? Does anyone have any questions? Yeah.
Do you have a graph comparing against R? Do you have a graph to show current comparison against R on certain things? Is there any chance?
That's a good, I don't think there is. There should be.
Yeah, I don't think there's a systematic comparison. There's like a R integration that kind of works, and I think there's various blog posts comparing Pandas to R. I think the last one I saw was on the parser when Wes first wrote the faster CSV parser in C in Python, and that it blows R out of the water at that time. I don't know if R and R stats of course keep on improving. Hadley spends a lot of his time and energy engaging in shooting match with Pandas. So,
and merging as well. That's some bit of
convergent design.
Okay.
And I want to, before we switch over from the notebook, I just wanted to highlight a couple of things that Andy mentioned. I'm going to switch back to the, is this one? No. So I just want to highlight a couple of things that Andy used in the notebook that we haven't seen before. So with matplotlib, there's a easy integration in Pandas where you can just call dataframe.plot.
So so I did do some cheeky stuff here. So I used pivot table, which I don't know how many people have seen pivot table. So when you have your data frame which have lots of different columns, and you want some of the columns to be the values and some to be in the index.
Yeah, it's exactly what you would expect from the Excel pivot table builder. And I think there's another feature up here that we looked at, which was the merge.
Oh yeah.
The merge function here, and that's essentially just a join, SQL style join, and so if you think about some sort of correspondence between SQL and data frame, you'll see that in data frame, there's grouping pivot tables, there's group by like in SQL, there's filtering, and then there's SQL style joins. So a lot of the optimizations in the workflow comes from actually, instead of creating this complicated query to give you exactly the right data that you want to work with, you can just bring in a bunch more than you actually need, and then you keep refining it once it's inside the data frame, and you have all of the SQL features that you need and more.
So is that something that's called denormalization?
Yeah.
Cool.
That's actually very interesting. How does it figure out which the ID?
No, so it does it on any overlapping columns by default. So if they're named the same, it just checks that they have to both be the equal. Yeah, so if there's only one the same, it just doesn't on that. If there's two the same, they have to both be equal.
Yeah.
Yeah.
You can override that. So you can say, left on and right on and have different keys.
But you might need to dirty the name a bit.
Right.
Yeah, so yeah, it's really useful, like this denormalization of SQL tables. Like if they're pretty small and you can fit all of them denormalized in a data frame, you just do it, and then so that way this name of the test is a whole column, and yeah, it's okay. There's lots of repeats there, but I don't care. I just want to have a look at the head or whatever. I want that kind of context that I don't get if it's just an ID.
Any other questions on this notebook so far? All right. So we have a bit of time left. So before we sort of turn it over to questions, I wanted to just highlight a couple of last points. Is it showing up okay with the full screen? Okay. So the priorities in open source development for Pandas has always been, top priority is build the right abstractions and give the right API to the user. And give the right API meaning API that fits the common use cases and makes it easier. I think this was about 3 years ago, and I was talking to a lot of users, and I think one of them told me that, hey, I started playing around with Pandas, and over a weekend, by the end of the weekend, I was asking questions like, hey, I wonder if I can do X in Pandas, and the thing that I guessed was actually just a Pandas function or a method. So those are types of APIs that you want to create where it's totally intuitive to the user, it's familiar to them, and fits their workflow and their minds. And getting the API right is super important because with open source projects, you might have a lot of users that end up depending on this API, and once people start using it, this is a good problem to have, by the way. Once people start using it, you can never change it. And I think there were, especially in the early days, there were a lot of angry GitHub issues. Oh, you changed this method and it broke my code.
There's still angry GitHub issues.
And I think in general, especially with open source, once you make an API, you can add to it, you can improve it. Rarely are you allowed to change it, and you can never ever delete an API. And I'll show you an example in just one slide here. And then finally, once you have the API right and you've abstracted away the client code from the underlying implementation, then you use tools like vBench and you use user reports against other benchmark things like R performance, for example. Then you optimize the performance and you improve upon that. Okay. It's going off the screen here, but basically, that's fine. It's just documentation repeated 3 times. But basically, it's you do want to serve as many users and use cases as you can, but sometimes you can't make everyone happy. So you want to find you want to find sort of a happy medium when you can. But once in a while, you just have to make a choice, because if you try to be all things to all people, sometimes you just end up being nothing to anyone.
So there was a time where we changed the API. I can't remember if it was something with lock, where some user then were upset on GitHub, but it turned out what they were doing before was just being garbage collected, and it wasn't doing anything. And so actually, a lot of what they were doing was completely wrong, and they were very pleased that we changed the API. So sometimes it's okay, but you want to be throwing warnings, and we do throw warnings or exceptions, telling you why it's changed. I think that's really important.
Yeah, absolutely. And so one example of in API sort of data structures changing underneath the API is data frame just started out in life as just a dict of series, right? You have the key as the column name, and you have the series as the data. Dict of series it's a bit simplification, but it's essentially what it was. And then there was also this thing called the data matrix, and the data matrix was a 2D homogeneous D-type data structure. So the API was roughly the same for data frame and data matrix. Underlying implementation was different, and for data frame, row-wise operations were inefficient. For data matrix, anytime you had to add or remove a column, that became very inefficient because you had to copy the entirety of the data. And so, I think pretty soon after I think Wes figured out a pretty clever optimization, which is you have the same API. We already have the same API, so it's fine. And the underlying implementation becomes you group all of the columns of the same D type into blocks, and you sort of hide this implementation detail that separate it into homogeneous blocks with a block, what's called a block manager data structure. So not only do we have a huge performance gain, but we also have now just one data structure instead of two. Now, as an example of what I mean when I say you can never delete APIs, data matrix still exists and is just aliased from data frame to this day. And so the last thing I'll say is just here's a couple of things that to note when we optimize for performance. Again, it's not just performance for performance sake. It's performance to make it so that we can beat other tools that people would commonly use and find frustrating that Pandas is slower, or things that will speed up so that it becomes interactive for people. So if something takes 10 seconds and we can make it take 1 second, that's a huge difference for an interactive workflow. And we do that by pushing slow code paths down to Python or even directly into C in the example of the file parser. And algorithms wise, we just got to be careful about minimizing cache misses. Loop through the data in accordance to how the data is actually laid out. Try not to create unnecessary copies. I think that's one thing that R and especially MATLAB falls prey to. If I think a lot of times I work with R. I have like 16 gigabytes of memory. I load in a 1 gigabyte file and I touch the keyboard and my memory just blows up. And that's because everything creates a copy. Any operation creates a copy. And then the last thing that differentiates Pandas from other libraries, and even not just other languages, but even other libraries in Python, is that Pandas tries to be very careful about NAs. So, for example, in Numpy, if you take the sum of an array and you have some nans in there, the output will be nan. But if you have a equivalent series in Pandas, you'll get you get a result that's with the nans and nans removed. So so that's not necessarily that actually makes performance optimization a little bit harder because when you write the algorithm, you have to be careful to check the NAs. All right. So yeah. So I think that's all the things I wanted to say. And that's your notebook. All right. So that's all the things we want to say in the presentation. Let's open it up to questions if you guys are still not tired of hearing us talk.
So the last step you said is publishing the data.
Yeah. Well, publishing here, I just mean like plots, so like dot plot and things like that. You know, with publishing, I would say your best bet is if you're, well, it depends on your audience, but IPython Notebook is a great tool. So you can make custom JavaScript widgets. You can make the tables a little different. You can add JavaScript snippets and things like that. So there's a lot of different ways.
This is like scrollable for the whole set you can look at, which is pretty useful sometimes.
What kind of sort of missing value imputation does Pandas support going forward? Because, like, I guess one method that's kind of common but very difficult to do by hand is like fit a linear model, not to all my complete cases, but to all the data with initial guesses for my parameters, and I keep updating and iterating as I find my model more and more time. Is there support for that kind of thing?
There's definitely something.
Yeah.
There's definitely something. I'm sure I've answered a question about that before. For linear ones, definitely, between 2 and A's. And like the standard ones that are fill forward and just filling.
Right, so...
but there is something. I think I can't remember if it's a method or if it's from another library. But
yeah, so I think the simplest ones are just filling it with value, filling it forward and backward in time series, interpolation. And I think
there's an interpolation method to interpolate.
So I don't know how advanced your use case is. From the sound of it, chances are you'd have to do something a little custom, because there's the missing data imputation is a whole PhD thesis. So.
Once again, getting back to presentation, looking at all the analytics in Python, which are all very, very powerful. It seems like the design center primarily revolves around science notebooks. But as you shift into more of like the SaaS world, the web application world, and let's say a company needs to use Pandas in the back end, what do you suggest you do from a presentation standpoint with, let's say, REST framework in the middle, and let's say a JavaScript query at the front end, and plots utilizing, let's say, pie charts and data tables as opposed to the Matplotlib? What would you suggest? Are there libraries, APIs that do, let's say, JSON type of thing?
There's a toJSON function for data frames, so and you can just send that, and then I guess work out whatever D3 or something.
It will convert things directly into, let's say, rows, like a bar charts.
Yeah, essentially, there's it uses the UJSON library. Right?
Yeah.
And it just converts it into rows of records.
You'd have to look at some D3 plotting or whatever plotting on the JavaScript side.
This is built into Pandas? Or
mm-hmm. You can export the JSON in Pandas.
Oh, okay.
And then I think there's IPython widgets, so you might be able to use. I'm not
well,
sure,
I mean, if you have the
that's
JSON format, you know, if you already have the rest of the web application in place, once you've converted to JSON, then your choices are very wide for tools. One thing I would say is be careful how big your data frame is. Generally, like and what you're plotting it with. If you're using SVG, there's an upper limit to the number of SVG elements you can plot effectively in the DOM. But there's experiments people have done with other things like Canvas and WebGL that works better. But sometimes Canvas the API is not necessarily great, but WebGL doesn't always work.
I've got another question related to that.
Okay.
Okay.
Can I come back? I'll come back to you.
Yeah,
is that okay?
That's fine.
Well, I have two high-level questions. One, to get back to the issue of how heavyweight it is. Does this run okay on an Amazon micro instance? Do I need something bigger? And the second question is that the signal processing community found useful.
Let's see. Well, it'll run fine on a micro instance. I haven't tried to build it on a micro instance in a while. I think it should still work. It just takes a little bit of tweaking so that I think you can use, if you can use you might have to use like change the swap space or something like that. I forgot the exact configurations for building it, but
Wouldn't you just use Anaconda Mini?
yeah.
I was just trying to get scale.
Yeah, if you just use the pre-built stuff, it should be totally fine. The signal processing depends on the use case. There's no I don't think, to my knowledge, there's no FFT integration in Pandas or anything by default. So.
Just sort of the abstraction on top of it.
I mean, I'd be not to my knowledge. I'd be interested in discussing afterwards in detail, like what do those abstractions look like and what are the use cases.
Kind of going to the presentation theme, if we haven't worn it out. Do you guys know of anything interesting that anything particularly interesting that somebody's done with Pandas and U3?
Lots, I guess. but so there's a lot of library, but it generally comes down to like Pandas becoming JSON object gets plotted in D3. So you can check out so one of the canonical ones, if you check out Rob Story's libraries, like Vincent, Bearcart, those types of open source libraries. They provide really good examples of how do you get from the data to visualization.
Yes, so speaking of putting stuff in production, there's support for streaming structures,
Not really. So there's HDFS5 like support. So I guess that's not really streaming. But I guess you can like use Pi tables to kind of do that. Not really.
Yeah, so I guess it depends on the frequency of data. In general, the aggregation functions and the algorithms in Pandas, they're not really made to be. They're not online algorithms. So it would be easy to say, okay, let's just start accepting streaming data, but then how do you actually use it? When you call mean or standard deviation, for example, you'd have to compute it on the entire data set again as new data arrives, so that's not very efficient. Oh yeah.
Yeah, I had on bad idioms. I have a little.
So yeah, so let's.
Python notebook.
Sorry, let me answer this gentleman's second question, and then we can switch over to bad idioms.
Well, thank you very much. Seems like Panda is really ideal for slicing and dicing large records. So if you have, let's say, a database table with, let's say, 100,000 records or more, and currently, let's just say a person utilizing just regular ORM Django to do slicing and dicing, and you're operating in a SaaS environment where you're very concerned about memory consumption for the user. What's a trade-off from a memory consumption standpoint? Let's say utilizing a data frame, huge data frame, and let's just say what Django ORM.
I don't, Andy. I don't know if you're familiar. Maybe you're more familiar about this than me. I'm not totally familiar with the memory profile of the Django ORM. With Pandas, you'd have to basically it's the amount of memory it takes to load that much data into Numpy arrays. That's essentially the memory it would take for you to load it into Pandas data frame. The caveat is you have to have a little bit of extra memory for the column labels and the row labels, and then there's a couple of cached in-memory indexers that's internal to the data frame itself. So it's not so much how much memory the Pandas data frame is going to have, but really just how much memory will that much data take up.
When I want to do things like Excel pivots, I see references to two things, two different kinds of ways of doing it. One was like a pivot method, another one was a pivot table.
Yeah.
Is one depreciated? Are they both equal? What's the recommendation?
So pivot's more sensitive beast. Like you have to have the right number of. You can't have any ends at the end. Whereas pivot table is much more flexible. You can have an aggregation function. So if there's two things that have the same index and column, it applies that aggregation function to the result. Whereas that's not the case with pivot. So pivot's more efficient, but you need to have a correctly structured stuff to begin with.
All right. You want to do the bad idioms?
I'll quickly run through the bad idioms, but we'll publish this after the talk anyway. So. So there's two data frame methods. There's a pivot method and a pivot table method, which is confusing. I don't know what the history is there, but those two are slightly distinct. They're basically the same. They also had different argument names, but that's recently been corrected, and depreciated. It's another API change for chain. Okay. So I'll just run through a couple of these because I didn't do it very many. The toolbar. So these are just a few things that many people do, but are less efficient generally. Using lots of apply. So here you're doing like apply and then a lambda, and that's quite difficult to read. But also you could just do a .sum, and that'd be more efficient most of the time because it's written efficiently in Python. And also each time it's doing this apply, every row it's making a series of the row, which can be more expensive because it has to change it. If it's an int and a float and an object, it upcasts that whole row into a new object. So it can be quite expensive. But yeah, I guess you see this quite a bit because some other, like GraphLab and some other companies are using the Pandas API to interface with their project, which I guess shows that the Pandas API is pretty good and well thought through. But there's some slight inconsistencies with the way they do it. Also, yeah, use Pandas datetime. So it's quite easy to go back to I know about Python's datetime. I'm going to use such and such a method, but that's much slower than using these efficient synchronized datetime methods that we have in Numpy and Pandas, because obviously the int64s underneath and efficiently written. And in the next release, 0.15, coming soon, I guess it's always coming soon, there's a DT attribute that you can run all these datetime methods off if you're in a series that's full of times, whereas previously you used to have to wrap them in a datetime. If anyone has any questions, we can. And something quite a lot of people, if you've got some complicated algorithm and you want to iterate through your rows, there's this function called iterrows. But that can be very slow if you're iterating through loads. So be careful when you use it. And if you're modifying, stuff, be careful. I'm conscious of time, so I'm going to rush through. But I'll make these slides. These slides are going to be available after. Also, there's this thing called chained assignment, which is, for a long time there was no warning, but now we're pretty good that we raise an error. So if you do this .iloc00 on a data frame, that's actually going to mutate a copy and then just be garbage collected. And previously it didn't raise an error, so people were doing this stuff and then were confused at why it wasn't working. But now we raise. But it's always but df00 works, the top one. But I think it's always better to do it in a single assignment. So then you're sure it's gonna work. And don't build up data frames piecemeal. I guess like in Python, you don't usually build a list like that. So you can neatly build these big frames, just concat frame. So build bigger ones together and then combine them all. Okay. Yeah, and so Chang was talking about methods using index rather than position, and that's really important. So if your lists are slightly, if your series have a different index, then when you add them together, it's not going to work. It's not going to be 2 and 4 like you might expect it to be. It's going to be 3 and 3. Okay, and non-unique index. So I think someone was talking about that before. You've got to be really careful because everything slows down when you've got non-unique index. So that was all I had. So, okay, good. Has anyone got any other questions or general? Go ahead.
Is there a good place to go to get the kind of latest thinking on which APIs and methods are the best?
No.
Well, the up-to-date Pandas documentation in pandas.pydata.org has a lot of good examples for all parts of the API. And on Stack Overflow, there's a lot of existing questions, but if you ask a new question, probably Andy will answer.
Yeah.
So.
Yeah, because there's a lot of documentation, I guess. So
Yeah.
Quite a big ask to read through all of it. Anyway.
Okay. Great. All right. Thank you.
Okay.